Hi everyone, today we're going to finish Unit 8 with 8.11 pH and solubility. So this last topic here is relating to the common ion effect and how pH will affect that. So if we think of acetic acid, CH3COOH, or another way to write it is C2H3O2, or sorry, HC2H3O2, that will dissociate to form H plus and acetate anion. This is an incomplete process because it's weak, and so it doesn't fully dissociate. Now, sodium acetate, this is a strong electrolyte, meaning it fully dissociates in water. So if we think back to the common ion effect, as a result of this, the presence of sodium acetate in an acetic acid solution shifts equilibrium back to acid. The idea here is if I have CH3COOH plus water, that's going to make acetate NaCH3COO, or sorry, it's going to make acetate ion, which is CH3COO minus and H3O plus. If I add this into my reaction, it's going to overall shift the equilibrium to the left. And so in a buffer solution, adding more of the salt is actually going to shift the equilibrium to the left, which decreases the concentration of H3O plus, which will decrease the pH of the solution. And so this kind of goes back to what we were talking about, the common ion effect, where if you add more of one ion, it's going to essentially make it less soluble. In other words, if I add sodium acetate, this makes this acetic acid less soluble. It applies to weak bases in exactly the same effect. And so weak bases, if a solution contains a weak base and a salt of its conjugate acid, in this case NH3 is our weak base, its conjugate acid is NH4+, the base won't dissociate as much as if it's alone in solution. And so if I add NH4+, what this does is shift the equilibrium back to the left, which lowers the concentration of OH minus. Basically, POH goes down, pH will go up. And so the solution becomes a little bit more neutral as a result. We'll discuss this a little bit more in class and go over some practice problems, but for now, that's all. Thanks, guys.